have discussed about what an algorithm is and how to write an algorithm and how to determine the time, determine the time complexity and space complexity. So today we will see about fundamentals of algorithm problem solving and how to determine the time complexity of a non-recursive algorithm. So can you explain the steps in solving the problem?
The fundamentals of problems algorithm is understanding the problem. First we need to understand the problem and decide the computational measures and designing an algorithm, and then next prove the correctness and analyzing the algorithm. If we are facing the any issues in prove the correctness or analyze the algorithm, we repeating the second and third step repeatedly, and then the final step is determine the order of growth. If the algorithm is given the output only, it goes to the last step.
So once you have written the algorithm, you have to check if the algorithm is working correctly for the given input. So you will give a sample input and you will check if it is generating the correct output. So if you find the algorithm is not producing the exact output, it means either you have understood the problem wrong or you have designed the algorithm wrongly. So you have to repeat the steps again. Again, when you are analyzing the algorithm, if the time complexity is huge, again it means the algorithm you have designed is not efficient, so you have to redefine it. So in these two steps, if you find any fault, you will repeat the steps from 1 to 3 again. Clear? So now we have understood the steps for solving a problem. So if you want to analyze the time complexity or if you want to determine the order of growth, it varies from algorithm to algorithm. So there are two types of algorithm. One is non-recursive, other one is recursive algorithm. So there are various steps in solving a non-recursive algorithm. So first step is, what is the first step is, you have to find the input parameter. So what is the input of that particular algorithm? Then you have to find the basic operation. So basic operation is nothing but the operation that determines the output of the algorithm. That is the basic operation. So in general, this operation will be present inside the loop. So third is, you have to find the best, worst and average case time complexity. If you want to calculate it separately or not, that you have to decide on. And fourth step is, you have to write the summation function for the basic operation. Then you will determine the order of growth. So you explain with an example.
Here you can see with an example of a unique assumption problem. If two numbers are repeated in the same array, it loses its uniqueness. That's what we are going to find. Take whether all the elements in a given array of n elements are distinct. The problem is solved using the following problem. Here we are using the non-recursive method. Uniqueness of an element. Here given an array of elements 0 to n minus 1 elements. Here we are using the two loops. One is from here we are starting the next element, checking if two elements are same or not. For each element, ma'am explained about 5 steps. First we are checking what is the parameter of the given input. Parameter is nothing but the input size of an array. Here the size is determined by using the n. Second step, we are checking what is the basic operation of the given algorithm. Here basic operation is nothing but we are checking whether the two elements are same or not. That's a determined if statement. If a of I equal to a of j, this step checks whether the two elements are same or not. Hence it can be determined as the basic operation. Third operation is to set if you are taking two array, if the input values are changed, the number of steps performed will be same. We does not want to carry all the same best to worst and average cases.
This point is like, so consider two arrays of same size. We have two arrays same size but the values are different. So the number of comparison required will remain the same or different?
Same.
It will remain the same. So if it remains the same, you need not calculate best, worst and average case separately. If it varies, you have to calculate it separately. So in this case, it will remain the same. So it is enough if you calculate the worst case alone.
Next, the last step is forming a summation function. Summation function is nothing but we are forming the summation for the loops around. Here we are having two loops. First loop is nothing but I is equal to 0 to n minus 2. Second loop is from j, I plus 1 to n minus 1.
So this summation is similar to your integration function that you have studied in maths. So we will have a lower limit and an upper limit. So lower limit is the starting value, upper limit is the ending value.
And here the basic operation is executed only one time for each loop. If j is taken as 1, the original operation is executed only one time. Hence we are denoting 1. We have a separate formula for the summation function. Summation of I equal to summation of 1 is equal to upper bound minus lower bound plus 1. Hence we are substituting n minus 1 is an upper bound, lower bound is I plus 1 plus 1. Hence we are cancelling, we get n minus 1 minus I. Here we are taking the constants n minus 1 as a separate summation. And taking the I as a separate. Hence we get the time complexity as an theta of n square, order of n square. For n square is determined by, we are taking two loops, two for loops. Hence the time complexity is minus n square.
Before calculating, directly by looking at the algorithm, you can see there are two loops. If there is one for loop, time complexity will be order of n. If there are two for loops and size is n, order of n square is the time complexity. So here we have two loops. So at last you are getting answer like n square minus n by 2. So this can be written like n square by 2 minus n by 2. When you are determining order of row, you will take the maximum value of n and n square is greatest. So you are taking order of n square as time complexity or order of row.